Okay, good morning everyone. I think we can start. Today I'm going to present a short commercial presentation about fast cure epoxy prepreg systems with press molding processing with the focus on automotive industry to show you what is the benefits of this kind of epoxy systems and how it's connected with automation and scaling up the production. I would like to start really short with the company introduction. So I represent company CMP GmbH. So if you develop this short sentences in our company, this means customer meets perfection or custom-made prepregs, because we are a prepreg manufacturer. So we were established in 2011 and we own different quality certificates also for aerospace, since we are a qualified Airbus supplier. Apart from that, we also have serial automotive applications, and this is something where we are going to focus today some more. But we also supply our materials to different markets and applications. We have two prepreg production lines, and one of them has a span of width for the prepreg impregnation up to 2 meters, which is again quite smart and efficient for the future applications in automotive if you think about car bonnets and car bonnets and roofs. In 2018 we made a turnover of roughly 13.7 million euro, and in terms of our philosophy we are mainly focused on prepregs and certain carbon and other technical textiles UD fabrics. We are a clean tech enterprise. We try to recycle our material, and we have a new state-of-art facilities. We are trying to be not only supplier but also a technology partner for our customers, and it comes from different ways to approach the projects. We try to be flexible, so we have a short lead time and minimum order quantities, and we always try to help the customers solve the issues. So this is our angle and our philosophy on approaching the industry. When you think about the field of application, roughly 30% of our application is connected to aerospace. Next biggest factor is automotive. Then we have industry and military, and then we have diverse applications. In terms of markets, we are operating globally. We have different customers in different industries all over the world. Here you can see the available resin systems. Today we will focus on the resin CP012, which is close to the right corner of the resin matrix, and we will talk some more. But if you have any questions about any other resin systems, we can discuss this afterwards. Just in short about prepreg machines. So we are a prepreg manufacturer. We have a hot melt based manufacturing system. We are able to achieve quite tight characteristics of our prepregs. One of our unique and key points is that we are able to impregnate any or just quite a lot of different technical fibers. We have a special machines which allow to keep the fiber properties and use high tow fibers for production of UD prepregs. This is what I already mentioned, and we also produce lightweight prepregs for aeronautic applications, again UD with light tow fibers. Of course, we also integrate woven fabrics. We produce textiles, prepregs from textiles for armoring, and that was about it. And now we can focus on our core of the lecture, so demand for mass production in composite industry. And before we go deep in the epoxy systems and the fast curing system, I would like to just draw a clear picture of how the industry looks like and why fast curing systems might be of benefit for the industry in the future. So and I use the numbers from Carbon Fiber Market Review, and according to the data there, carbon fiber reinforced plastic, so-called CFRPI, was named as the end use in the product for approximately 80% of total carbon fiber global production, which is quite a lot. And from there, 128 kilotons of carbon fiber, which makes 128 kilotons of carbon fiber, so roughly 70% of the turnover for the whole market. And there, thermoset matrix systems covers roughly 90 kilotons, which is 70%. So just to summarize, CFRP is the highest end product made out of carbon fiber, and thermoset systems at 70% of the whole CFRP production output. In terms of market and applications, the biggest market for carbon fiber reinforced plastics is, of course, aerospace, defense, and then comes automotive. So when we think about aerospace, of course, we have a really big turnover there and high prices and big investments, but this is mainly coming from demanding qualification and safety requirements. And this market is obviously high performance driven, which allows to introduce new materials, but this is again very conservative market. Then we have defense industry, where we have really big scale projects and mass investments. Again, high performance driven market, and they have a readiness and capacity to innovate. And then as a third market, and this is the market which will, as most of the prognoses are saying, is going to gain more and more momentum in the composite industry, it's automotive. So we have second larger CFRP consumer in terms of volume, so it's 37 kilotons, and turnover, which is more than 4.70 million of USD dollars. And this is the reason I'm going to focus on this, because the CFRP application in the automotive market is yet to come. So it's just introduced there, but it's not really there for the mass production, but it's coming. And the scale effect is so enormous there that it really makes sense to pay attention of what's going to happen in this industry. So yeah, for defense and aerospace, as I already mentioned, it's a performance-driven market, it's less sensitive to cost layup, and entrance barriers are quite high. So this is the reason the standard art of the production of the composite parts could be maintained as it was initially designed for aerospace and defense. However, if we think about automotive, and sport and leisure is also another great example, the requirements there and business model around this market is really, really different. So for a long time, most of the new applications which are coming to automotive, they have to adjust to automotive philosophy, not the other way around. And this is the reason the standard setup of composites production is not really working in the automotive. And this is also one of the reasons previously the main application for the composite parts in automotive were for high-end cars and for just cosmetic or design applications, but this is yet to change. And when we think about composites and CFRP in automotive, the production philosophy haven't been changing since 100 years. But the one of the big factors which might speed up the process of introduction of composites in this industry is, for instance, CO2 emission regulations, which are coming in play for OEMs. And this is creating a really big challenge, because for the most of the automotive manufacturers, they don't really want to change the whole design of the car. They don't want to create new blueprints. They would just like to keep the things the way they are, but reduce the emission. And in a short-term period, it's not really possible unless you reduce the weight of the car. And this is where the composites come in play. And this is where there is this competitive angle of composites, because they're really good at weight reduction. But to do that, to offer something really interesting for automotive, we have to learn how to really transfer our products to the philosophy of the industry. And this is where the fast Q systems are coming in play. Another example is sport and leisure market. It's also a market which is driven by performance by end products. But the introduction of the novelty material is way easier, because the safety norms are different, and mass production is also a must if you want to keep the price-wise competitive edge of your products. So in our opinion, both markets are going to drive demand towards CFRP in the coming years because of the scale of their production, and they will kind of lead the further development in this field. because the short cycles, consistent quality, and rapid scale-up of the production is a must in both of the markets for the future. So after this short introduction, the first advanced composites to enter the automotive market were conventional thermoset resins connected with the carbon fiber textiles, and that was basically taken from the aerospace industry and tried to be implemented in automotive. As I mentioned, this ended up in high-end, price-wise driven products which were not really scalable. This is the reason it was used for high-end cars and racing industry. It gave, of course, outstanding performance and weight saving when it was needed, but it was really slow because mainly autoclave and in some cases out-of-autoclave applications were used, but that was really, really slow. Yeah, and this is the reason. This approach has to be reinvented in roughly 10-15 years ago. The industry started to think about creating the fast Q system. And of course, we have not only thermoset, we also have thermoplastics. So I'm going to focus just in quick in current state with thermoplastic SnapQ systems. The problem with the thermoplastic is that currently there are material constraints coming from thermoplastic matrices, and they're limited from dimensional stability and the heat distortion, and this is quite crucial because for the whole automotive process, again, it's not going to be adjusted to the composite industry, and the composite industry has to adjust itself to the automotive process. And one of the requirements is higher TG, so roughly 135 degrees for the further assembly of the car, and this is where today the thermoplastics are not able to stand, and this is one of the examples. There are a bit more constraints, but this is one of the reasons that thermoset matrices in this application, they prevail. And of course, material-wise performance-driven thermoset matrices are a bit better. So as we can proceed, we have SnapQ thermosets system which is being developed since a couple of years, and we have standard epoxy. So the problem with the standard epoxy is that they require temperature ramps, they require slow temperature increase and dwelling points, and this all lead to really long processing times, which means that the production of the parts is not really efficient. Therefore, to apply this to the automotive philosophy, the approach has to be reinvented. So the SnapQ was invented. So because the cycle of the production has to be shorter, the viscosity had to be increased to allow the wet out of the whole textile. But the problem is that it still has to be delayed and postponed to a certain point when the fast cure could happen. And this is there was a big technical issue, and this also means that it required a lot of additional development. So this led to the resin time with a good thermolag and delayed onset reaction, which allowed the full impregnation in the short time. So the high, so the high liquidity of the resin, and then curing in a setup temperature. And this is something that standard thermoset resins are not able to offer. And when it comes to today's thermoset epoxy systems, we have two different approaches. So first is resin transfer molding, and second one is press compression molding. And I would like to show the differences between two of them. In theory, the basic process is kind of the same. Basically, we have the carbon fiber textile, and we align it in a certain form. We do the preforming of the dry textile, and then we apply the resin in the RTM process, and then we have a component. The key factor of this process is able to control the cure process properly. And the benefits of RTM is definitely that you can achieve way more complex parts, as for instance with press compression molding. But the issue is also the time of the cure, because if the part is quite big and it just takes more time, and you have to have a really good equipment capabilities and know-how. However, with press compression molding, the things are becoming a bit easier, because you have a prepreg, so the uncertainty about the differences between the different textile is not there, because you receive from one supplier the already made product in terms of resin and the textile. You also do preforming, you apply the press molding, and then you have a component. So you can only so this allows you to focus only on the cycle itself and keep it as short as possible, because more variables factors are out of play in comparison with RTM. So you can just focus on end characteristics. However, with the press compression molding, thicker parts are a bit more difficult to produce. Another issue is that complex parts are also might be difficult. So this also requires a bit more time to develop every part, especially if you want to keep the short cure cycle. But this is one of these aspects where we can help our customers, and we can provide some technical support. So again, the differences between RTM and press compression molding, I already mentioned a couple of them, but to come to the conclusion, in comparison to RTM, the outstanding feature of the press compression molding seems to be commercial one. From the commercial perspective, it's easier to scale up the production and to grow to large series, because you can focus on the shorter cycles, and this gives you lower cost and the competitive advantage. And this is actually the feedback that I'm really getting from the market. We are already speaking with a couple of RTM customers who are losing in terms of competition to the car part manufacturing using fast cure systems and press compression molding. So even though their main focus is RTM, they're approaching us and trying to develop this way of processing as well, because when it comes to simple shape parts and the scale of the production, the press compression molding system is really winning in comparison from commercial perspective. Okay, and now we can focus on the real examples. So we're going to go through two case studies with CP012 resin, so our thermoset resin, fast cure system, and the end applications. So yeah, so just really short about the resin itself. So the commercial name is CP012. You have a Q temperature between 120 to 180 Celsius. The Q time between 15 to 3 minutes, but it really depends on the part shape and the expected results. So this is the reason. This is something that it has to be, of course, developed. The pressure between 2 to 6 bars, with the high viscosity, which is again needed to properly wet out the textile during the cure. TG 135, and this is something that I already mentioned. TG has to be a bit higher than standard 120 degrees, because this has to be aligned with the further processing of the part with the assembly, automotive assembly process. Because this is a highly reactive fast curing system, the room temperature is shorter. In this case, it's 3 weeks. In the terms of the textiles, we can impregnate all kinds of textiles, which gives, of course, design freedom for our end customers. So yeah, just one of the things to mention also, which is quite important. This is so-called hot-in, hot-out system. So because of the process require heating up 2 sides of the mold, it's really important in terms of getting the production cycle shorter, is to have a really easy demolding feature, and this is something that we also try to achieve. This is the reason we have this hot-in, hot-out feature, which means that after the curing, you can really easily demold finished component from the mold. Okay, so in terms of the specific examples, and we as a CMP GmbH, we supported our partner from China, Dongguan Action Composites, and developed and brought to commercial use carbon fiber reinforced composite stabilizers for the front and the rear axis of the racing car series, and you can see them here. And actually, for this, we were rewarded with GAC award in JEC Asia last year. And just from the perspective of the end customer, the key benefit here was replacement of the specific element of the car with 55% of the weight saving. And we proved to OEM that they can align carbon fiber reinforced plastics with their process. This is usable for semi-structural part of the car, and we can align it with the car manufacturing philosophy. So those are the CFRP elements, and parts shown on the picture could be manufactured in less than 6 minutes, offering to opportunity to produce 220 parts per day, which gives approximately 70 parts annually. Of course, you have to also calculate the components which are scrap parts and all the factors. So you could say between 50,000 to 70,000 parts annually. But again, that's proof the points that you can have a mass production with composite parts, and you can bring the value to the automotive customers. Some other applications. So there is approximately 8 square meters of our fast cure prepreg in every GT2 and GT3 Porsche, 7 different parts, and you can see a couple of them. So the rear, the side mirrors and the exhaustion element. Just to summarize the whole presentation. So, in my opinion and the opinion of the market, the fast curing epoxy systems and compression molding are prove the point that the composites are applicable for the automotive industry. However, the automotive industry itself, with the composite part makers, they have to always put some additional effort in the part design and the processing development, because of the speed of the curing of the prepregs. The whole process goes so fast that it requires really tight calibrations. But again, this is the additional value which we can bring as a supplier of such a system. So the limitations as for today is, as mentioned before, the thicker parts could be problematic with fast cure systems, especially with the press compression molding system. There are also limitations coming from design. So with such processing methods, the best way to benefit from it is just to use it for very simple shapes. And one of the current trends, and this is something for what the whole industry is fighting for, is to provide the visual look parts with the press compression molding system and keeping the cure time very low. This is really hard to achieve, and this is something that we are also working on. Now we have some early success results with German OEMs, and we'll be happy to support you, dear listeners, if you have any projects like that, because this is probably where the future is going to be. So once again, thank you very much for your attention. If you have any questions, feel free to address them.